Good morning everyone, and this is continuation for lasers topic, and the next topic is absorption and stimulation. There are some important phenomena of laser. They are absorption emission, spontaneous emission, stimulated emission. Now let us discuss these phenomena in detail. First one is absorption emission. Here in absorption emission we will have two energy states. They are E1 and E2. Here E1 is known as lower energy state or ground state, and E2 is called higher energy state or excited state. See here, in this absorption emission we will consider two energy states E1 and E2, and we will consider an atom in E1 state. Now we will give some energy from outside to this atom, and now this atom will absorb this energy and it will move to E1 state to E2 state, that I have represented here. It will move from E1 to E2 like this, releasing an energy of delta E. Delta E equal to E2 minus E1. This is all about absorption emission. Simply we'll consider two energy states E1, E2, and we'll have an atom in E1 state. We'll give some energy to this atom. This atom will absorb this energy and it will move to E1 state to E2, releasing an amount of energy delta E, where delta E equal to E2 minus E1. This is all about absorption emission. And now the spontaneous emission. In spontaneous emission, atom is already excited to E2 state. That is, we have already seen it from first phenomenon. Atom has already moved to E2 state, that I am representing here once again. So now atom is in E2 state. Now this atom which is present in E2 state will de-excite from E2 to E1 after completing its lifetime. That means it will de-excite, that means it will again move from E2 to E1 once this atom will complete its lifetime. And the lifetime of an atom in excited state is 10 to the power of minus 8 seconds. That is, the atom whatever is present in E2 state will have a lifetime of 10 to the power of minus 8 seconds. Now, during this process, the atom will release photon, which is shown in the figure. See here, the atom will already present in E2 state. After completing a lifetime of 10 to the power of minus 8 seconds, it will once again de-excite from E2 to E1, releasing a photon, that is single photon. This is all about spontaneous emission. Simply we'll have two excited states as in the earlier state, and the atom will be present in E2 state. Now after completing a lifetime of 10 to the power of minus 8 seconds, it will simply move from E2 to E1, releasing a single photon. Coming to stimulated emission, here actually the lifetime of an atom in excited state is 10 to the power of minus 8 seconds, that we have discussed in spontaneous emission. But before this lifetime is being completed, if we again give some energy to the atom in excited state, it will de-excite from E2 to E1, releasing two photons. That means we are already having an atom in E2 state which is having an energy of h nu, but still before it completes 10 to the power of minus 8 seconds, if we again give some more energy to this atom, that means again I am representing it here, this atom will actually have h nu energy, but before it is completing 10 to the power of minus 8 seconds, once again I am giving some energy again, that means h nu plus h nu. Now this atom is having double the energy. So now when it is de-exciting from E2 to E1, it will release 2 photons. See here, it will release 2 photons. The one which is the photon whichever we have given it from E1 to E2, and another photon energy we are again giving before it is completing 10 to the power of minus 8 seconds. So when it is de-exciting from E2 to E1, it will release 2 photons. Simply, stimulated emission is nothing but we are having same 2 energy states. Atom will be present in E2 state containing h nu energy, but before completing 10 to the power of minus 8 seconds, that means before it is completing its lifetime, we are once again giving h nu energy to this atom. So when it is de-exciting from E2 to E1, it is releasing 2 photons. One photon whichever we have given to the atom to move from E1 to E2, and the second photon whichever we have given as an additional energy to this photon. So 2 photons are getting released. The difference between spontaneous emission and stimulated emission is, in spontaneous emission will have single photon in de-excitation state, and coming to stimulated emission will have 2 photons. Thank you.